Hi everyone, my name is Vanita, and today I will be covering a project I have been working on for a course that I'm taking at Duke University. I have learned all about AI and machine learning foundations for product managers in a 6-week course. We learned about the different types of machine learning, the challenges of modeling, and some strategies to overcome them, along with being able to identify the algorithms used for common ML tasks and their use cases. We also covered what deep learning is and the strengths and challenges relative to other forms of machine learning. Lastly, we learned how to implement best practices while interpreting and evaluating machine learning models. The project we worked on contained over 9,500 rows of data over a period of 6 years, and the objective was to build a model to predict the electrical energy output of a combined cycle power plant. The tool that I ended up using was Google AutoML and Vertex AI because it made it very easy to look into the data without having to code. There were 4 main features or inputs in the data: ambient temperature, exhaust vacuum, the ambient pressure, and relative humidity. The target output was the net hourly electrical energy output. So as you can see, when I ran the data, it looks like there were 0 missing counts, meaning this was very clean data, and that saved us an immense amount of time. Typically, more than 50% of an analyst's job is to cleanse the data. For the machine learning approach, the first step is to identify the type. In this case, we identified this as supervised learning, which was the best type since the data contained past known features and target variables. The data was continuous and structured as well. Then, of course, we were to find the best output metric, and lastly, complete the validation of the model. For algorithm options, I chose the linear regression model because it's a great first step and simple to interpret. Some of the other options we covered in this course were random forest, gradient boosting, and AutoML. Some factors to consider when choosing an algorithm is accuracy, interpretability, and computational efficiency. In this case, linear regression had quick results. I initially trained the data and had it split with the 10% for testing, 10% for validation, and 80% for training. This was a default setting in the tool, but I agreed with those values. The results above show that ambient temperature was the most important feature and exhaust vacuum was the second most important feature in comparison to the pressure and the humidity. I ran the model with the ambient temperature as the weighted column. In this case, the RMSE method was used since large errors are not acceptable in a power plant energy output prediction. For evaluating model error metrics, the key findings that we came to was that ambient temperature and vacuum drive energy output prediction. The performance metric we used was the RMSE metrics, which stands for root mean square error. It takes the root of the square differences between the predicted values and observed values. The lower the number, the better it is. The value of 5 from the previous slide is not too high, but it's also not considered super low. The above is the training data for deploying to the endpoint. I took the test data into the model to start predicting, and based off of those inputs, the predictions ranged from 445 to 485, and the energy output value was 460. This was roughly within 95% in range, which is fairly close. Some of the key learnings from this project were seeing how features are rated by importance and which ones to select as a weighted feature. For example, in this model, the temperature was one of the weighted features because it was evaluated as one of the most important ones. Another key learning from this project was being able to run a linear regression model and why it is a good starting point for most projects. Lastly, being able to choose a performance metric. In this case, RMSE was chosen due to large errors not being acceptable in a power plant energy output prediction. Now that comes to a wrap for the presentation and on the project. If you have any questions, my contact email is on this slide. Thank you so much for taking the time to listen. Have a nice day. Bye-bye.